So our first example is here. Remember that we want change in y divided by the change in x. So first I'm going to look at my y values and I'm going to count the changes here. So from negative 2 to 2, it's increasing because we're going from negative to positive by 4. Negative 2 to negative 1, negative 1 to 0, 0 to 1, and 1 to 2. From 2 to 10, also increasing. It's getting more positive, further away from 0. And then that's increasing by 8. My x coordinates, again, are increasing, and that time by 2, and here increasing by 4. Okay, so I found the changes in my coordinates. Now I'm going to divide them. So my first change in y was positive 4. I'm going to divide that by my first change in x, which was positive 2. Now they're both even, so I can simplify this or divide top and bottom by 2. 2 over 1, which is 2. My second change in y was positive 8. My second change in x was positive 4. Now these are both even as well, but if I divide them by 2, they'll still be even because there's a bigger even number that can divide both of these, and that number is 4. So simplify by dividing top and bottom by 4. 2 over 1. Well, that's the same thing I got here. So the rate of change is the same between both points. That's important because when the rate of change is the same between both points, that means it is a linear function. And if it's a linear function, that means if I graph it, it's going to make a straight line. So if the rate of change is the same between all the points, it's linear and it makes a straight line on a graph. So example 2, the table's written a little bit different than we saw up there, and that's okay. It's still the same concept. So what I want you to do is hit the pause button, try this on your own, look at the work above to help you out. Just hit the pause button, try it on your own, and then we'll go over it in a minute or so. So we want change in y divided by change in x. The first change in y was, that's increasing by 1, and that's increasing by 2. So 1/2. Now I could leave it like 1/2, or if I like to turn fractions into decimals because I don't like fractions, and what I could do is 1 divided by 2, and that'll give me 0.5. My second change in y was 2, positive 2. My second change in x was positive 4. So positive 2 divided by positive 4. Well, those are both even, so I can simplify by dividing top and bottom by 2. 1 over 2. 1/2, that's the same as the other one. So this one is also linear. If I graph it, it'll make a straight line. The slope, the rate of change, or the speed happens to be 1/2. Now, 1/2 is smaller than 2. So what that means is that this line with the slope of 1/2 is going to be not as steep as the slope of 2. So they're both positive, but 2 is going to be a lot steeper. It's going to change a lot faster than 1/2 will. Because the larger the coefficient, the steeper the line. The smaller the coefficient, the more shallow or flat the line. Okay, now, so we just found rate of change from a table. Now we're going to find rate of change from points. Well, it's the same thing, because if we look back at what we just did, technically this is still a point. A table is a set of points. This has 3 sets of points. 1, 2, 3. This one has 3 sets of points. 1, 2, 3. Now we're going to see just 2 points. Okay? We still need the change in y divided by the change in x. Now if you can't remember which one's the x and which one's the y, just think about the alphabet. Okay? Ordered pairs are in alphabetical order. X comes before y in the alphabet, so x comes before y in an ordered pair. My change in y from positive 3 to positive 9, that's going up, it's increasing by 6. From positive 2 to positive 4, that's increasing by 2. So my change in y was 6. My change in x was 2. These are both positive. Now remember, they're both even, so I can divide top and bottom by 2 or simplify. And I get 3 over 1, which is 3. So that's even steeper than the rate of change of 2 in the last example that we saw. Alright, so your turn. You see my work from above. See exactly what I did. Change in y divided by change in x. Okay? Do it on your own. Hit the pause button, and in about a minute we'll go over this. So the change in y, I'm taking my y coordinates. Remember, y coordinates come second in an ordered pair. From 5 to 8, I'm increasing by 3. From 1 to negative 2, now I'm decreasing again by 3. So my change in y was positive 3. My change in x was negative 3. Well, that can be simplified if I divide top and bottom by 3. So that's a positive 1 divided by a negative 1. So a positive divided by a negative is a negative. 1 divided by 1 is 1. So that rate of change, slope or speed, is negative 1. So that's going to change slower than a positive 3. It's not going to be as steep. So there's 4 types of rate of change, or slope or speed. And you always read rate of change, slope, and speed. If you have a graph, you always read it from left to right, just like you read a book. Always read from left to right. Okay, so this one, from left to right, it looks like it's going upwards and over to the right. We call that a positive slope. It goes up from left to right. Next kind, it's going downwards from left to right. So imagine you're starting at the y-axis. Imagine this is your bank account. From left to right, it's going up. That's positive. That's a good thing. You want money in your bank account. This one's going down. That's a bad thing. That's negative. You don't want that. Okay, so negative slope. Also, if you draw vertical lines on either side of the graph, that makes an N. Can you see that? How it makes an N? If it makes an N, it's negative. N for negative. The third kind is a horizontal line. That makes an H if you draw the vertical lines on either side. Okay? That has a slope of 0. Okay? Now there's a special word that you can use to help remember the situation of a horizontal line, and that word is HOI. So H is for horizontal, O is for 0 slope, because a horizontal line has a slope of 0 or 0 slope, and the equation of that line, and we'll talk about that later, is y equals a number, and in this case it's y equals 1/2. Okay? The fourth and final type of rate of change or slope or speed is a vertical line. So a vertical line is going straight up and straight down. Okay? That has a slope that is undefined. Imagine trying to run up a wall. It's kind of impossible due to gravity, right? You can't really run up a wall. You're going to fall on your face and look silly. So vertical lines have a slope that is undefined. Okay, and you learn more about that in pre-calculus and calculus. Okay, it's actually called an asymptote, so it's kind of a big vocabulary word you can take away for the day. So vertical lines have a slope that is undefined. Now there's a special word here that you can use to remember the situation about vertical lines, and that is VUX. V for vertical, U for undefined, because the slope is undefined. And in this case, it's x equals a number would be the equation of a vertical line.